Good morning guys, welcome to the Dbms session. Guys, in the today's lecture we will try to discuss about that ER model. Before starting the today's session guys, we'll try to recall the things of previous session. Actually in the previous session we have successfully completed the weaves in SQL, right? So first we discussed about the what is meant by weave, then why weaves are required, right? Then how to create a weave, the syntax used to create a weave that we have discussed. Then after that we entered into the few more concepts of weaves, that means when weaves cannot be updatable. So we discussed in the previous session, so weaves cannot be updatable, especially when a weave is created by using multiple tables, and as well as when a weave is created where it contains an aggregate function. That means if weave contains created by using an aggregate function and a group by class, then such weaves cannot be updatable, right? So these were the two important things we discussed, especially with respect to weaves, and we have explored also, right? Fine. Then after that we entered into one more wonderful concept of SQL that we called by name, how we can cascade that updation, or how we can cascade the deletion operation across the database tables, right? So that we have discussed. Probably we have seen that especially without deleting the secondary entries, that means the foreign key entries, we cannot, the SQL doesn't permit us to delete the entries in the primary key table column, right? So suppose if any updations if I want to perform, it always asks us suggests us to do the changes or updation deletion as what we plan to perform it on the secondary tables, that means in the transaction tables where all we are having this entry, right? So for that we said we have to manually search and go through each and everywhere, and we have to modify it or delete it like that. We need to do that, means without making any changes in a child row, then it doesn't permit us to make it in a parent row, that means in the primary key row, right? So primary key table. So for that what we did is, instead of manually searching where all this entry is present, right? So across our database, because our database might consist of plenty of tables, right? So what best thing we can do is make use of on delete cascade and on update cascade, kind of a beautiful option, right? So that we have explored in the previous session, especially when we make use with a foreign keys, right? When we go with creating a foreign key, suppose if we attach this keyword, then how beautifully it performs that cascading of this updation and deletion operation that we have seen, right? So fine. So now guys, today in the today's session I am with one more very interesting topic of SQ, that Dbms, that we call by name ER model. ER model basically stands for entity relationship model. Actually ER, it's an acronym used for entity relationship, right? So before starting the today's session guys, we should know, that means before learning the each and everything aspects of ER model, first we should know why this ER model is required, right? So especially how it, in what aspects of the database Dbms concept are in the database it helps us, right? Is it helpful for query writing, or is it helpful for design perspective, right? So in what way, for what perspective, or for what purpose we should learn this ER model, that we have to think first. Guys, actually basically this ER model is mainly useful for us in understanding a requirement, and as well as based on our understanding of requirement, that means systematically after understanding the requirement, we'll go with designing of a database, right? So directly will not be, once after going through the requirement, so we'll not go with directly drawing a tables, right? Instead of that, we'll go with one more high level conceptual data model, right? So this high level conceptual model, the design as what we do, once after analyzing the requirement, once after the process of requirement analysis, right, from the real world we'll get a problem, right? That means we'll go through the problem, then after that we'll analyze it, its feasibility study, that all we'll do as part of our software engineering, right? So then after that, once after the successful requirement analysis, then what we'll do is, we'll go with, suppose if it requires, if it is, let's assume for time being it's a database project, so during the time it is required to store some huge amount of data. So to store it directly, we'll not go for designing a database. Instead of that, we'll go with this ER model construction. That means it's a primary step before, especially for designing, before designing a database, we can call, right. So that means especially in designing a ER model, we are having a plenty of components of its own, that means ER model components. So that we should know, guys. That means once after learning the basic principles of behind this ER model, then definitely we can construct a very good database. That means especially to design a right database, it is better to know the ER model construction. Suppose if you are good at in finding all entities, relationships which are present in the given requirement, right, in the problem statement, right. So in the scenario, then definitely we could construct a very good database, right. So with and it should be in a right normalized form also, in a good normal form. So that also we will discuss it in a suitable normal form. What is a suitable normal form for a given set of scenario, right. So that all for a given scenario, that all we will see it. So for time being, let's we'll restrict ourselves to a ER model. I said it's a where E stands for entities and R stands for relationship. And I said there's a relationship between these entities to entities, that means entity types to entity type, with the help of one relationship type. So before starting it, we'll try to discuss about what is meant by entity type, what is meant by entity, what is meant by relationship, relationship type, attributes, right, all such things. Then what is the notations which are used especially in the ER model, right, what are the standard notations, then how to make use it, right, how to connect it, then how to build an ER diagram, a high level conceptual data model, or we can say a primary step of a database design process, how to achieve it, right. So once if we are successful in building a right ER model, guys, then easily we can convert that ER model into a relational database schema, right. So that means actually we can consider that ER model, that ER diagram as what we write, for a given scenario. We could consider it as just converting the scenario, that means a requirement, most of the time it's a scenario kind of the problem statement, right. So we are converting the scenario, that English statements, the scenario statements, in terms of a diagram. It's a diagrammatic representation of a requirement we can consider. So where it contains what are all the entity types, that means what are all the real world objects which are present in the given scenario, right. Then what are all the things it constitutes, then how one and the another object, that means how these objects are interrelated with each other, right. So all such things we can learn in this ER model, especially those things will represent in terms of a diagram in case of ER model. So guys, we'll take one small scenario to know about all these basic minute things or the components of this ER model, right. The first one is entity type. So before going in terms of entity type means what, a definition, where we'll try to consider one example. Along with that example, we'll try to map this concept. That means, oh, this means this is a component of this ER model, like that, right. So let's say for example, guys, we'll consider a college management system or a school management system kind of a system. So where especially in a college or a school management system, we go with storing a huge amount of data. Definitely we can consider it's a college management or the school management project is a database application, right, where it requires too much of data to be stored, right. So can we identify what are the different kinds of entities, that means an objects which comes in a college management system or a school management system where we need to record the data, right. So suppose when you consider like that, so most of the time what is our interest is, oh sir, college consists of students, right. A college management system usually consists of a student. Then let's say it consists of a student. Then sir, college even it consists of a branch, right. So then after this we'll say, sir, college consists of teachers, yes, right. And student joins for a branch, right, and teacher also belongs to some branch, right, and teacher teaches some subject, right. So this also be there, teacher teaches some subject and student study subject, right, like that. That means we are having, let's assume for timing, we'll try to restrict ourselves only to this much. That means student belongs, we are having a college where college consists of plenty of branches. It's an indication that I want to store, let's say I am having a branch like MCA, MBA, and each branch having a HOD, right, having a name, right, and it is located in some location in the college, right, it's having each branch having its own dedicated phone number, right, such kind of a thing. So if you want to, and when it was started, right, the branch started date, year, right, so all such things if I want to record. So these are all the things which are all connected to a branch, right. So for that when I say branch in the college, most of the time we'll go with saving these many data items, right. So the data related to a branch means branch name, and how we can identify each branch in a college. Let's say for example with a branch ID we can consider in terms of database. Let's assume for example branch name will record, then we'll record HOD of the branch, right, all such things. Then when I say teacher, we'll say in the college each teacher is identified based on teacher ID, having a name, right, and teacher having a date of birth, teacher having a phone number, address, many other things. When I say teacher, we'll go with recording all these details related to a teacher, right. So or we can say for example if a teacher like let's assume a teacher ABC, the name of the teacher ID is 1 and name is ABC, then he born in the year some 1990, then 10/10/1990, let's assume these are the data I am recording, and he belongs to some branch something. These data if I am recording means this I'll record. Let's assume I want to record 100 teacher details, means each teacher details. Let's say for example 1, 2, 3. I am having 3 teachers. So T1, T2, T3. So 3 teachers I am writing. So these teachers, all 3 teachers, when I give a form to fill their teachers, when I want to fill a data related to these 3 teachers, what they'll do is, they want to enter, sir, I want to write a teacher ID, sir, I want to enter a teacher, my name. Then they'll say, I want to enter the address, and they'll say, I'm having a phone number that I want to record. So all such information they want to record. Let's say a teacher T1, he'll enter teacher ID T1, T2, T3. T1 will enter teacher name as some A, then address as some Mysore, then phone number 9986 something, right. Then teacher 2 says, no, even I am also having a ID, name and address. He also fills a data. Let's say assume Balu, then Bangalore, then 886 something, right, they'll enter. Then teacher T3, so his name was Raju, then they want to enter some Mysore, then 7865 something, they'll enter some phone number. So here every teacher, this T1, so this data is what we are having, it is connected to this teacher T1, and this T2, this data which is connected to teacher T2, and this connected with the teacher T3. It's an indication that every teacher having their own values for all these columns, right, we'll say. Then what exactly this TID, T name, address, phone number, what exactly this represents? We can say in general we call it by name. All these 3 are, we'll call it as what, guys? Teachers. In general we'll say T1, T2, T3, all these 3 are teachers. That means, and these T1, T2, T3 will have their own values for all these columns. And teacher can be described, this can be described, that means it contains a component. When I say teacher can be described, that means it contains these minute elements, TID, T name, address, phone number, right. So we can call it by name. These are all the properties of a teacher we can call, or we can say how we are describing a teacher, or what information we are planning to collect from each of the teacher, right. So that all constituted and they formed one thing, and that we call by name a teacher, right. So here also same thing, and all these instances, all these are all having their own values. It's an indication that they become the instance of this teacher, right. And in general we call all together this as will with one same name, or T1, T2, T3, they are all teachers, right. We are giving one name. That means the name, these are all what, guys? The instance of a teacher. T1, he is an instance of this teacher. T2, It's an instance of a teacher, or we can call it by name, it's a mold. From this mold, we get this T1, T2, T3 like this. How in a Ganesha festival we are having, almost, have you seen guys, I have seen that idol, almost all 100 idols with the same shape, same size, same height, weight, everything, right, even with a single mouse, right, also things. It's an indication that these are all obtained from a single mold, right. Here also same thing, we are having a mold like a teacher. From this mold, we are getting these instances, and all instances having their own values. Could be that, so we'll get a same Ganesha but with different color, Here also same thing, they'll give a different one, this is a Ganesha 1, 2, 3, 4, here also same thing, T1, T2, T3, T4. It's an indication that the name given to that mold here is a teacher, and we call it by name this as an entity type. We call this as what guys? Entity type. Teacher is an entity type. And what about T1, T2, T3 here we have written? These are all the instances of this entity type, or we can say the instance. Usually if teacher becomes a class, then T1, T2, T3, this becomes an instance of that class, we'll call, especially in case of in an object oriented language, right. If suppose if we want to talk it in terms of object oriented principles, we'll call it by name teacher is a class, and T1, T2, T3 is what we have written, So them we call it by name as an instance of that class or objects of that class. Here also same thing guys, these are all the objects, right. So objects of this entity type, and these objects we call it by a name entity. Each one is an entity. These are all entities, that's it, right. So each minute thing we call by name entities, and the name given to this set of entities, and this we call by name entity type. And it's all collected, T1, T2, T3, all are connected, are all collected, and they are all grouped together, right. Each we call by name an entity, and name given to this set or a group of entity type, it's a teacher, and we said it as an entity type. And it is looking like a collection, T1, T2, T3, collection of objects, right, collection of instances, or you can say the collection of entities, set of entities, right, where all these entities will have their own value and share the common attributes, right. So they are having some attributes and they are having their own values for these attributes, right. They are having a common property, we can say. So teacher ID, teacher name, address, it's a property of interest in which we have recorded under a teacher or to describe a teacher, right. So they are having their own values for it. And this collection of these entities are a set of these entities, and this we call by name. It is looking like a set, T1, T2, 3. What kind of a set? It's a set of instances, set of objects, or set of, basically in terms of VR model, if I want to explain, then it is what? A set of entities, where T1, this is an entity E1, let's say call it by name some instance E1, and it's an instance E2, and it's an instance E3. T1, E2, E3 are all the instances or the entities of this teacher, right, teacher entity type, belongs to teacher entity type, and collection of this E1, E2, E3, and this we call by name an entity set. That means a collection of entities where each entity, where all entities of that set shares a common attribute, right, are having a common property of interest, then or belongs to a same entity type, then such set we call it by name entity set. What is that guys? Collection of entities where all entities will share a common attributes, right, having a common property of interest or belongs to a same entity type, then such set we call by name an entity set. And entity type can be described as it's a name given to a set of entities, or we can say the name given to a collection of entities, right, we can say, right. And this entity type can be further described, that means can be described as TID, T name, address, right, that means contains its own property of interest, right. These are all the properties of a teacher, that means an entity type, right. Next, where entity is an instance of an entity type, that is it, right. So, these are the three things we should know, especially before drawing an ER model, right, before designing an ER model for any given scenario. What are the things we discussed? One is entity type. It's a name given to a set. We can say this is a set, right. For this we have given a name, or we can say it's a table name in general. Suppose since we have learned about, we have come across with SQL, not the design aspect, directly the table. So, for that we are aware of the table, right. So, table name is an entity type you can call, right. And table contains what, guys? Attributes, TID, name, address. Basically it is what, guys? Attributes. Here we call by name the properties. Properties of what? They are properties of a table, there we call, but here what? The properties of an entity type, that is it, right. Next, we are having a table contains a rows, it contains plenty of rows, where each row represents what? A student data. Suppose if it is a student table, if I say 1 Ashok, some ABC, something like this, the student USN, name, address, phone number if I record, then 1, 2, 3 as what we record, each row represents what? An instance of a student, right. That row, each row or each tuple represents an instance of a student. Here each row represents an entity of the entity type, right. That is it. So, row represents an entity and name given to a table is an entity type, right, and collection of such rows, in a table, then that we called by name here an entity set, that is it. Now, we compared this ER model with ISQL, that is it, right, fine. And like this, even subject also we can say that subject having a code, subject having a name, and subject belongs to some semester, like that we can further describe. And here student having a USN, student having a name, right, like that we can describe. Branch having a branch ID, branch name, having a HOD, such kind of a thing, right, we can describe further. Under that we will record plenty of data. Suppose if I want to record a 10 branch details, means this branch having 10 entities, and name given to that set of 10 entities we call by name a branch, right, that is it. Suppose if I want to talk it in terms of an object oriented fashion, then we can say entity type is a name given to, it's similar to a class, that is it. Name given to a class is an entity type. And TID, T name, T address as what we have recorded, it is the properties, that means the members of that class, that is it, data members of that class. And what we are having, T1, T2, information related to each teacher, that means rows of a table, that we call by name the object of that class, that is it, right. Now, we listed these three things, the components of ER model. We'll go with a listing out few more components of this ER model now. I said a teacher means an entity type, and we said it contains a teacher ID, teacher name. For time being, I will take out this one. You can take anything, no issues. I am having a student kind of a entity type, and how we can describe a student, what student can contain, or what information we want to record with respect to a student. Means few of my friends will say, sir, student having a register number, a USN, sir. Then student having a name, student having a phone number, a student having an address. Can record even teacher also. Why I took the student is we are very much aware of the student, teacher and all. Even I will record the teacher also. So under this USN will record many other information. Then what exactly the things is what we have collected here, So related to student. When I say student, suddenly how we say something, for example, when I say this elephant, suddenly what comes to our mind is, already I said, big leg, huge body, right? So all such that information, all such components of that elephant will come. Here also same thing, when I say the student, suddenly, oh, student contains a US and student having a name, right? So that all things actually we want to record, that all connected components of the student, or we can say what makes the student, right? What constitutes the student, right? So that comes to our mind. So here then these properties as what we have recorded, as a property of interest as part of the requirement as what we have collected here, that means it is an interest or the data in which we want to record under each of these column of the student, and this we call it by name, guys, attributes. And this we call by name attributes of this entity type. Then how to represent this entity type? Here we are having, how in a table we are having it, it's we are representing it in terms of two-dimensional array, that means it consists of rows and columns, right? So collection of rows and columns, that we call by name table, right there. Here this is what in SQL structure, it's SQL way of defining, but in case of ER model, to represent these attributes, as what I said, the properties of this entity type. What is that? The properties of this entity type, that we call by name attributes. Attributes, right? And these attributes are represented with the help of this oval shaped symbol. And I said these are all connected with whom? It is connected to the student, because this all belongs to student. Is it belongs to a teacher? No, it all belongs to what? A student. So that will connect it like this with the help of these lines, right? So don't go with writing an arrow mark, right? So directly simply connect it with a line. This is what a notation used. And but we have not represented the student in terms of a elliptic symbol or with the help of this oval shaped symbol. Instead of that, we have represented with what? With a rectangular box, right? So this is what a notation used for that entity type. I'll write. So along with this, I'll try to write the notation used for these things. The notations used. Notations used in the ER model. A rectangular box for entity type, and entity, it's a minute instance that will be recorded in the database, right? Those things. Then entity set, it's a collection of entities. We don't have a separate notation for that. Then attributes. For attributes in the ER model, we'll represent it, right? So this property of interest attributes are represented with the help of what? Oval or elliptic symbol, right? With the help of this symbol. Fine. Next, we are having a different types of attributes. Do you have any? Definitely observe, guys. So each student is not identified based on a name, or not identified based on a phone number, or not based on an address, right? It's an indication that we'll identify each student based on a USN. It's an indication that there are the attributes also having some categories. That means having its own types. And one more, let's say for example, when I say address, when I give an address kind of a column for a student, then suddenly the student will go with writing, sir, I want to write my house number, let's say door number, I'll write. And few will say, sir, I want to write the street, sir, I want to write the cross number, I want to write the city name, district, they want to write the pin code, many other things they want to record. They want to write, they want to belongs to which state, these things. Actually, here look at this one, guys. So how student can be categorized, in the same fashion, even we are further decomposing that address it into many minute components. But we'll say, so it's not an entity type, here we call it by name, it's an attribute. But this attribute is further having a plenty of minute components, many simple components, right, we are having, right? So that means, so this is different from this one. Then could be, it's an indication that So we could have different types in attributes also. Now my next topic is the types of attributes. Let's say we'll try to list it here and we'll write it, types of attributes. Look at this one. This USN we have not further decomposed, but this address we have decomposed further. It's having many minute components. Let's say for example this USN, can we further decompose? No, only one number will enter, so that we cannot further decompose. Let's say a phone number, can we further decompose? No, we cannot decompose like this. That means there are few components which cannot be further divisible. We cannot further decompose. It doesn't have many minute components within it, right? So then such attributes, that means when it is not further divisible, look at this one, here it is divisible like that, contains plenty of components, right? So then when such component or when any attributes which cannot be further decomposable, then such are further divisible, or we can say it's having a indivisible format. We cannot further decompose, divide, right? So then such attributes we call it by name. It's a very simple. This itself is a simple component, so for that we cannot further divide, right? So then such attributes we call it by name simple attributes. Right? So exactly this one is opposite to this one, these three. Or we can say, suppose if I want to, let's say sometimes we have seen that in the form, name contains a first name, last name, initials, right? So these things I can further divide. So now name is of what type? Name and address. These two are the attributes where we are dividing. That means constituted with the help of these three components, right? So for that we can decompose, divide, right? So then these attributes, name and address, these kind of attribute we call by name, composed of many simple attributes, but this I cannot further decompose. Cross number, can we further decompose? No, not possible. It doesn't have many, we cannot divide further, right? So then such attributes, look at this one, if attribute which can be further decomposed are composed of many simple attributes, then such attributes composed of many simple attributes, right? So then such attributes we call by name composite attributes. Attributes, simple attributes, that itself is simplest form, right, where we cannot further divide, but composite attributes can be further divided, we can divide, right, and can contains many simple components, right, many simple attributes we can call, right, many simple attributes constituted and they form one composite attribute, right, like this. And one more, have you seen that guys, student is not identified based on a name. When I say Raju, then there could be possibility that in a class there are 5-6 students might have a same name with a Raju. They say, sir, what sir? So out of 5, I cannot, it is not possible for me with the help of a name to uniquely identify a particular Raju, right? Is it possible with the help of a phone number or with address? Phone number could be possibility that my friends might say, sir, that people might have a unique phone number. Let's assume 3 students have given us come from a same two students come from a same house and they have given their father number. Let's assume the siblings, right? So during the time when I say a phone number, then suddenly 2% will raise their hand, then again it's a difficult thing for me to identify, right? So possibility that, can I say Mysore? So there are 20 to 30 members may raise their hand, right? So I cannot uniquely identify. So let's assume guys, we are having a USN. With the help of this USN, when I say the USN, only one person will raise their hand, right? So with the help of this USN, easily I can identify each student in the class or in a branch, right? So that we can do. And university will make use of same thing to identify, right? Out of plenty of students from different colleges. In case of SQL, we said this as key attribute. Here also same thing. We call this as a key attribute. and always the key attribute in DBMS are underlined. This is what a notation used for key attributes. There is one more attribute called key attribute. Look at this one. Try to get the differences. With simple key attribute is also a simple attribute. Along with that, the rest when compared to phone number are, let's say for example, if I say date of birth, I am having one more attribute. Student having a date of birth, that also I have recorded. And date of birth, phone number, USN, these three are simple attributes. But out of these three simple attributes, when I say 25, 5, 19, 90, it could be possibility that there could be more than one student might born in a same date, right? Who knows? Might have a same date of birth, right? So date of birth also doesn't have such a quality that where with the help of that I cannot uniquely identify each student in a branch or in a class, right? So what best we can do is with a USN, I don't have any ambiguity in identifying a student, right, in a class. So for that, this acts as a key attribute to identify, right. So then such attributes, then such simple attributes where it holds the property of uniqueness, right. So then such attributes we call by name key attributes, right, key attribute of that entity type, fine. And there is one more kind of attribute we are having, guys. Let's say I can store a date of birth, and once if I know the date of birth, once if we are successfully storing a date of birth, and with the help of this date of birth, can I say what is the age of the student? By knowing a date of birth, means if date of birth is stored in a database, by using the data, definitely we can compute the age of that particular student, right, that we can do. So then date of birth is very much required, to derive or to compute the age of the student. So sure, definitely possible, right. So then during the time this date of birth, let's say date of birth, what we are doing? Date of birth we are storing, right? Yes, with the help of this date of birth, we are deriving a one more attribute, right? We are deriving a one more attribute. What is that, guys? We are deriving the age of a student, and we have represented it in terms of a dotted oval symbol or dotted elliptic symbol, right? And this is what derived from, age is derived from what? Date of birth. Date of birth is what? Stored, an attribute which is simple and as well as stored, right? And these attributes we call by name stored attribute. This is a stored attribute. We have stored a date of birth, and we are with the help of date of birth we are deriving, right? So for that we have connected it with this date of birth, this derived attribute, and we have represented with dotted. Dotted indicates it's a derived attribute. It is derived from this stored attribute, right? So fifth one. So without date of birth we cannot derive a age. So for that age becomes what? Computed using or derived using date of birth. So for that it's a derived attribute. Fine. Next, let's say for timing I'll write phone number. When you ask a student, definitely he'll write only one USN, and you ask them, he'll not write two date of birth, he'll write only one date of birth. When you give a column like age, then he'll fill one age, but here we are deriving, no need to worry about that. Then when you ask for a name, he'll write one name, right? Even though it consists of first name, last name and initial, but once all are recorded in the different columns, right? 3 columns. That means we are having 3 simple attributes, simple components for this name. But when you ask for a phone number, suddenly he'll tell, sir, I am having 2 phone numbers, sir, I am having 3 phone numbers, sir. But here I have given only one text field, right? Then how can I enter? So could be this kind of a question they are having. That means for USN the student will not go for entering a multiple number, but for a name, even for that also he will enter only one name, and for date of birth he will go with only one entry. And suppose if I am having a father name, then for that also he will enter only one name. But when he go with when he finds that phone number, suddenly he will say, sir, I am having a multiple phone number, I want to enter under this phone number column, right? Then it's an indication that there are few attributes having a different characteristic. That means a different feature where it can take a more than one value, multiple values under that column, right? Then such attributes we call it by name multi-valued attribute. Look at this one. Sir, we'll write multiple student USN 1, 2, 3, 4. We'll write. But one USN 1, let's say 4M at 10MCA01, it belongs to one student S1. 4M at 10MCA02, that belongs to a different student. Now I am talking for a single student, if he is having a multiple values for some particular attribute, then such attributes we called by name multi-valued attribute. Are you getting? Fine. Next. But father name, blood group, when I say student having a blood group, right? B group I will record. So this attribute could be a possibility that in a registration form we want to record all such information. What about this one, guys? Which cannot be, it's again a simple attribute, we cannot further divisible, right? And with the help of these simple attributes, I cannot derive anything. So for that it is not a derived attribute, it's only a simple attribute. But along with that, for a blood group column, we'll write only one entry, only one value we can take, right? The student will not enter multiple value under a F name or a blood group and all such things, father name, right? So then such attributes, if any attribute which is simple and as well as it takes only one value, right? Only one value, then such attributes we call by name, what is that? Single valued attribute. Attribute, right? We have seen that for simple attribute the notation used is oval, right? For composite attribute the notation used is what? Right? Like this we'll write, we'll record these things. And what about key attribute? For key attribute we have used what? The attribute name will be underlined, right? For this. What about stored? Stored attributes will be what? Derived using what? Dotted lines. Fine. Next. Stored, this is stored and this one is what? Derived. Fine. What about multi-valued? So multi-valued attribute we have represented with a different thing. Let's say a phone number having a multiple phone number, right? A student having a multiple phone number, right? So that will be represented with what? This concentric oval shaped symbol, right? So that means one oval will be covered with a one more oval, right? So two elliptic concentric elliptic symbol that is used to represent a multi-valued attribute, right? I'll write it here. Right? That's it. This is what a symbol will make use. Then what about single valued? As usual, simple attribute. We don't have a different notation for that. Then after that, there could be a possibility that one of the courier boy is telling something. Sir, they are writing phone number even in address itself. They are writing the phone number in address, and one more, that letter contains more than one phone number, sir, more than one phone number. At this point of time, let's say for example, sorry, I have written phone number to name. Let's assume you can call. So let me write it here. USN key attribute. What is that? Multi-valued. Derived attribute. Blood group. Let's assume this is what? Single valued. Let's assume I'm having an address. What I said? A person has written an address in such a way that where it contains the door number, city, pin code, district, cross, along with that has written a phone number. That to what? Multiple phone numbers has written, let us assume. Multiple phone numbers means that always to be represented with what? Double O symbol, that means a multi-valued attribute symbol notation. So at this point of time, address contains many simple components. Along with that, it contains a component, contains an attribute where one of that attribute, that composite attribute component can take multiple values, right? So then such attributes we call by name complex attribute. Look at this one, complex attribute. What is meant by complex? Complex means it's a mixture of what? Composite attribute and as well as a multi-valued attribute. If any attribute, if it is a mixture of composite and as well as a multi-valued attribute, then such attributes we call by name what? Complex attributes, right? So the notation used is like this. So one composite symbol and at least one attribute should be what? Of multi-valued kind. If one composite attribute, if one of the components of a composite attribute, if it is a multi-valued component, that means a multi-valued attribute, then such attributes we call by name complex attributes. That's it, guys. Today in the session we have discussed about entity type, entity set, then after that we entered into attributes, then the types of attributes and the notations which are used in the ER model, especially for these attributes and entity types, right? So this we have discussed. Thank you. Thanks for your patience listening.